Our first topic for this year is called momentum. Momentum has been defined as the product of mass and velocity. So product simply means multiplication, mass and velocity. So for us to find the momentum of an object, we must multiply the mass of that object and its velocity. The symbol for momentum is a small letter P. The SI unit is kilogram meters per second or kgs meters per second. So this is the SI unit for momentum. So after doing your calculations, make sure that you put this unit at the end of your answer, and you also have to put direction because momentum is a vector quantity, so it needs direction. So here's the equation here that we use. P stands for momentum in kilogram meters per second, M stands for mass in kgs, V stands for velocity in meters per second. So momentum here is a vector quantity, it has direction. Mass is a scalar quantity, it doesn't have direction. Velocity is a vector quantity, it has direction. So at any given time, the direction of your momentum will be the same direction as that of the velocity of the object. So if your velocity is going to the east, then the momentum of that object is to the east also. If the velocity is upwards, then the momentum of the object will also be upwards. But we'll look at a variety of situations here. Now, another thing for us to understand regarding this equation is that, whatever happens to the mass, either the mass or the velocity, will also happen to the momentum as well. Take for instance, if let's say we have an object. Suppose I have this object, let's just say the mass is m, and I have another object, its mass is, let's say, 2m, 2 times the mass of this first object, and then the velocity of this one is v, velocity of this one is v. So these objects that are moving at the same velocity, but the masses are different. Now, what will be the momentum of object number 1? Since the mass is m, the velocity is v, obviously the momentum will just be p. But for this one here, we have doubled the mass of the object, so its momentum is actually going to be 2p, twice the momentum of the first object. You can have another situation as well. You could have objects that have the same size, some m and m, but if they have different velocities now, what will happen to the momentum? Suppose the velocity of this object here is actually 3 times the velocity of this one. What will be the momentum? So momentum for this one is p, because p is mv, but the momentum of this one is going to be, because I have tripled the velocity of the first object. If you double the mass of an object, you also double the momentum of that particular object for as long as you maintain the velocity. If you double the velocity, you're going to double the momentum of that object if you maintain the mass the same. And the same also works by reducing also. You reduce the velocity of an object, the momentum will also reduce. Okay. Now let's look at examples. Here's example number 1. It says, a car of mass 3,200 kgs is moving at 5 meters per second to the east. Calculate its momentum. Let's check the information that we're given here before we do the calculation. 3,200 kgs, this is my mass, m. 5 meters per second, this is my velocity, v. And I'm also given east as the direction, so I have direction here. Very important. Calculate its momentum. So we want to calculate the momentum of an object. Momentum is p. Right? So once I have all my given information, I then need to write the equation down and do the substitution and come up with my answer. But before we do that, we need to make use of our direction here. So the first thing that you always do before you do any calculation here, you must choose a positive direction. So you have to write this statement down. Taking east as positive. A very important statement to write, this one. You choose a positive direction. So either you're going to say take east as positive or take west as positive. So what this effectively means is that any velocity which is acting to the east is going to be positive, and any vector which is acting to the west is going to be negative. So this is what it means, right? So very important for you to do this very first step, very important. Then you then write your equation. P is equal to mv. Then you substitute. Your mass is 3,200 kgs, and then you're multiplying by 5. Now we saw that velocity is a vector quantity and is positive, right? My east is positive, so it means that this velocity here is going to be positive because it is to the east. So that's why I'm putting a positive 5 here. Okay, now we do a multiplication here. 3,200, so it's 3,200 multiplied by 5. That gives us 16,000. So 16,000 kgs meters per second. Now we have to put the direction here at the end of my calculation. Since my answer here is positive, right? You can see 16,000. This is a positive answer, right? So since the answer is positive, my direction is actually to the east because I chose east as positive. My east direction is positive. So whatever is positive is to the east. Whatever is to the east is positive, and vice versa. Okay, so that's how we calculate momentum. One can also decide to choose west as positive. So you can also say, okay, let me take west as positive, right? Like I said, it's a choice that you make. So I'm taking west as positive, meaning that anything which is to the west is positive, anything which is to the east is negative. Then I write my equation. P equals to mv. I substitute 3,200 multiplied by what? I don't have to multiply by 5 this time. I must multiply by what? A negative 5, because I have taken west as positive, but in the statement here I'm given east as my direction, so I need to assign the correct, assign there. So my value here is negative 5. So I'll get negative 16,000 kgs meters per second. Then I must now write a conclusion at the end of the day. Therefore, P is 16,000 kgs meters per second to the east. So I'm saying east here because my answer is negative. So since my answer is negative, it must be to the east, because whatever is negative is to the east. So this is my conclusion at the end of the day. So you choose a positive direction that you want to take. You write your equation, you substitute, making sure that you are putting the correct sign on the velocity depending on the direction that you've chosen as positive or negative. And then you then write your answer. Your answer must have the unit and the direction at the end. So whether you take east as positive, west as positive, we're arriving at the same conclusion at the end of the day. Right, so in this example, we are told that a 200-gram bullet, so I have 200 grams, that's my mass. It is fired upwards, okay, direction, at a velocity of 120 meters per second. Okay, that's my velocity there, v. What is its momentum? So I must find momentum, which is p, immediately after firing. Okay, so my direction is upwards, downwards. All right, so I need to choose a positive direction, so I can say taking upwards is positive. Okay, fine. Now I write my equation. P equals to, and initially my bullet is going upwards, so it means that this velocity here is positive because it's going upwards, and I've chosen upward as positive, right? And then I substitute. The mass that I'm having here is in grams, so I need to convert this mass to kgs. How do you convert grams to kgs? Simply divide this one by 1000. So 200 over 1000 gives us 0.2 kgs, right? So that's quite a heavy bullet. So we have 0.2 here multiplied by 120. All right, then we have to calculate 0.2 times 120, that's 24. So I get 24, that's 24. So I get 24 kgs, meters per second. What's the direction? Upwards. Since my answer is positive, the direction will be that positive one that I've chosen. All right. If you want also, you can take down as positive. So you can say taking downwards as positive. So it means that upwards is negative, right? Down is positive, up is negative, right? So I then substitute into my equation here. 0.2 is the mass. My velocity is negative 120 because it's going upwards. So I get negative 24 kilogram meters per second. Then I must now rewrite this. Therefore, P is equal to 24 kilogram meters per second upwards. Since I have taken up as positive and down as up is negative and down is positive. So that is how we do our calculations momentum. Very interesting, very simple also, but very profound.